Alright, so let's talk about special factoring and different types of patterns that we can deal with when we're factoring. One in particular is the difference of two squares. So what that looks like is when you asked a question to factor something like a squared minus b squared, this factors into a minus b times a plus b, and you can always check that by foiling out. So that's the pattern that we're thinking about first. Let's go ahead and do an example so we can practice with that. So first of all, let's start off with first example I'll do would be x squared minus 49. So when you look at that x squared minus 49, you should be able to notice that this could be thought of as x squared minus 7 squared. Once you think of it like that, then you can realize, oh, this is a difference of two squares. There's an a squared minus a b squared, which means this would factor into x minus 7 times x plus 7. So that is the idea of how to use the difference of two squares pattern. Of course, that can definitely get more difficult, so let's work on some more examples. What you should always do when you're checking your work is FOIL this out. When you FOIL this out, you should go back and get the original. That's how you check your work. Okay. Alright, so let's do another example. Okay, let's do a different example about special factoring. So the next example I'm going to do is going to be x to the 4th minus 16. Okay, so in this example, let's see if we can figure out how does this look like a difference of two squares. So this will look like an x squared squared minus 4 squared. Okay, again, as you can notice, if you're looking over here at this x part, x squared squared is x to the 4th. So it does in fact match up. So that's what we're thinking about. This is x squared squared minus 4 squared, which then is a difference of two squares pattern. So this can be the first one minus the second one, the first one plus the second one. So that's the x squared minus 4 times x squared plus 4. Okay, you might think you're done here, but what I want you to do is take one more look. Look at x squared minus 4. You should be able to look at that and notice that is again a difference of two squares. So you end up using this difference of two squares twice in one problem. This is now x minus 2 x plus 2. So that's how that factors. Now if you wanted to look at this in a different way, look at the x squared plus 4. Does this factor? It's not a difference of two squares. In fact, it's a sum of two squares. Sum of two squares don't factor, so that's just going to drop down as x squared plus 4. So you can't just leave it. It's still part of the final answer, but doesn't factor farther. Only the x squared minus 4 factored farther. Alright, so that's what happens with the original. The x to the 4th minus 16 now factored into x minus 2, x plus 2, and then x squared plus 4. Alright, so let's do one more example similar to this so that we can get some extra practice with this. Maybe the next one we'll throw in two variables. How about we do that so we can see more than one variable. So let's do 16. So next example I'll do 16x squared minus 81y squared. So let's talk about this one. See if we can recognize what this is. Is this a difference of two squares? So look at the first term. 16 is definitely 4 squared. So there's the 4 and the x that's being squared. 81 is definitely 9 squared. So it's the 9 and the y that's being squared. So this is a difference of two squares. So because this is a difference of two squares, we can factor this. It's going to be 4x minus 9y times 4x plus 9y. Okay, and now certainly those x's and y's aren't squared anymore, so I can't continue on with a difference of two squares. So that's how that one factors. Ta-da!